I wanted to work through a couple of these problems and just show you how we solve them so that you can go on and complete the rest of the worksheet. We're going to start with our very first one here, 10.250.1.1. And as you can see, it has a CIDR notation of a /24, which means 24 bits in the subnet mask. So we've got a 10.250.1.1, and again the equivalent of the subnet mask is 255.255.255.0. So based on this, we will you can quickly see that what comes through as the network ID is 10.250.1, and then because we have the 0 here, this 1 does not come down, so this then becomes a 0. All right, so your network ID is going to be 10.250.1.0. The next thing we need to do is we need to figure out what are the first host address, the last host address. And host address, this is an address that can be given to a device. So it could be a router, it could be a switch, it could be a PC, a server, any device that gets an IP address. So our first host is always going to be one more than the network ID. So our network ID, let's grab that, come down here, stick that in, and your network ID is going to be one more. Okay? Now, one of the things that I should probably point out here is that when we look at this this IP address and the network versus the host address portion, let me show this to you. Okay, so the first 24 bits are network ID bits represented by the N's. The last 8 bits, because there are 32 bits in a 32-bit IP version 4 address, the last 8 bits are host bits. Okay, so I've got 8 host bits. Now, anytime we said that anytime that your host bits are zeros, in the case of our network ID up here, you'll notice that your network ID is a 0 there, so your host bits are zeros. So that identifies a network ID. Now if we put in, and your first IP address or your first host address is going to be 00008 zeros, or I'm sorry, 7 zeros and a 1. Okay, so that's in binary, and that's equivalent to a 1 in decimal. Now if you keep counting through these, the very last 1, 2, 3, 4, 5, 6, 7, 8, okay, if you have 8 ones there, that's going to be equivalent, and that's in binary, that's going to be equivalent to a 255 in decimal. And anytime that all of your host bits are equal to ones, this is referred to as a broadcast address. Okay? So the very last host address is going to be so 7 ones and a 0, and that's in binary. And if you convert that to decimal, that's going to be 254 base 10. Okay, so this is where I'm getting this value of the first host address is 1, okay, right here. The last host address is 254, right there. The broadcast is 255, and then the host bits, well, that's the number of host bits that I've got right there, is 8 bits. And the way I calculated that is I took 24, subtracted it from 32, and that gave me my 8 host bits. Based on this, I use this formula for the number of hosts that I can have, which is 2 to the host bits. Okay? And the number of host bits that I have are 8. So 2 to the 8 minus 2 is going to be equal to 254. So if you do 2 to the 8, that gives you 256. Minus 2 gives you 254. So I can have 254 host addresses, and they are numbered from 1 to 254. Okay? Let's work on the next one. Let's see if I can do a better job of showing this to you. And we'll go back. I'm going to erase some of this. We'll get rid of that. Go up here, get rid of this. And so our IP address is 150.10.15.234. And again, we have the CIDR notation, and that's going to tell us that we've got 24 bits in the subnet mask, and if we write that out in dotted decimal format, that's going to give us 255, 255, 255. Remembering that 255 is equivalent to 8 binary ones, therefore 3 sets of 255 gives us 24 and 0. And if we line this up, okay, then you can see with the 255s that helps us to identify what our network portion is here, and the result there is going to be 150, 10, 15, and then finally 0. That is our network ID. Okay? Again, as we come down and we look at this, the network ID versus the host ID, you see that we've got 24 ends in 3 sets of 8, and then the remaining number of bits are going to be our host bits. So if you will, the network ID is all host bits are zeros. And that's where I get the, and I'm doing this in decimal just to shorthand it. But this last piece, okay, the host portion here, I'm just putting that in binary to line it up with the bits, okay? So that's binary, and that's equal to 0 in decimal, okay? Now, when we go to the first host address, it's going to be one more. So 00000, counting up in binary, that's going to be a 1. And that's equal to 1 in decimal. Our last is going to be with a 0 on the very end there, and that's going to give us a 254 in decimal. And then finally, our broadcast address is going to be 8 ones, which is 255 in decimal. So that's our broadcast, last host, first host, and our network ID. Going up, our number of host bits, you've got those right there, 8 positions for the host portion, so that gives you 8 bits. And again, we use that formula, the number of host bits, 2 to the number of host bits minus 2 is going to give me 254 for the number of hosts. So I've got 8 host bits. Let me move something out of my way here so I can see it. 8 host bits. And then if I go and I say 2 to the 8, that's strange. I thought I had superscripting in here. Well, I use another. When we used to use teletype machines, this is what this is the caret we used for raised to the power of. So 2 raised to the power of 8 minus 2. That gives us 256 minus 2, which equals 254. So that's the number of host bits that that we get. Okay. Next problem is going to be a little different. That's actually that is actually incorrect. We'll look at the we'll forget about the 192.14. We'll go to the 148 17.9.1. Okay. Okay, here's our next problem. And we've got an IP address of 150.10.15 and 234 with a /28. Now, if we write our subnet mask out in a dotted decimal format, we've got 255, 255, 255, which gives us 24 bits, but I need 28. So the value that I'm going to need here is 240. And let me show you, it's not like I'm doing a conversion and figuring this out in a binary decimal. I have simply memorized a table of specific subnet mask values. all subnet masks in a dotted decimal notation use a set number of values, and here they are up here in the upper right hand corner. We start out with 1 bit in binary and then 7 zeros, and that's equivalent to 128. Then 2 bits and 6 zeros for 192. 3 bits, 5 zeros, 224. 4 bits, 4 zeros, 240. So I need 4 additional bits because it's 28, okay? So the third octet brings us up to 24, and then I need 4 more. So I need 4 more bits. There are those 4 bits right there for a decimal value of 240, and that's what you see here. Now I'm going to write this out so you can see this a little more clearly. So okay, let's get rid of those spaces. And then I need 4 more bits here. 1, 2, 3, 4 for my network bits. And then the remaining are going to be my host bits. So as you can see, I've got 4 host bits. We'll just turn those to red. Okay? All right. Now I need to come up with some blocks here, okay? Again, we are going to look at what is the rightmost bit, okay? The rightmost bit is right there, and the question is what is the value of that? This bit is 128. This bit right here is 64, 32. This is 16, okay? So, what we need to do is we have a block size of 16, okay? And then if we take the formula and we say block size minus 2, then that's going to tell us the number of hosts. So if I've got 16 minus 2, that's going to give me the number of hosts of 14. Okay. Next, we want to come up with our multiples of 16. So here we are. We have our blocks now. 0, 16, 32, 48, 64, 80, 96, 112, 128, 144, 160, 176, 192, 208, 224, and 240. Because the block size is smaller than what we did before, I think we had a block size of 64. The 16 is a quarter of the size of the 64, so there are going to be more blocks. Okay? Last time we only had 4 blocks, 0, 64, 128, and 192. Because of the smaller block size, we have a lot more blocks. Now each one of these blocks is actually a network ID. So the network IDs would be, let's say, 150, 10, 15, 0. That's the first one. Then 150, 10, 15, 16. Then 150, 10, 15, 32. And then 150, 10, 15, 48. And each one of these is going to be a network ID. Okay? The IP address that we started with, however, is this 234 up here. And the question is, this 234, what block does it belong in? Where is it? Well, it's this value here, okay, because it's an IP address, is going to be, or a host address, has to be larger than its network ID. So as we take the 234 and we look at all of our network IDs here, we get all the way up to 224, and 234 is larger than 224 but smaller than 240. So it's in this 224 block that our IP address exists. So let's just take a look at this real quick. We've got our 150, we've got our 10.15 and if you recall, okay, our network ID is 224, okay, and if you come up here, all right, we've got 224 here, which is going to be 224. That's going to be the network ID. Okay. Our first host address is going to be 225. Our last host address, well, let's go to broadcast first. Our broadcast address is going to be the highest in the range. Okay, so, well, let's see. If I take 16, rather than doing that, what I want you to do is take the 240, which is the next network ID, and subtract 1, and that will give you your block size to this. Or, I'm sorry, not block size, so I'm sorry, your broadcast address. So we are going to do 239. And once you have the 239, then you can figure out the last address as 238. Okay? All right, so here are your answers for up above. And I just want to write this out so that you can clearly see what's going on here, okay? So our network ID looks like this down below. And I need to bump this up a little bit. Can't see one of the lines on this. Okay, and this is going to be 224. This is going to be 225. This is going to be 238. And this is going to be 239. All right. So try the rest of these, see how you do, and we'll be talking more about this. This is not an easy concept, gang, okay? Shortly, we're going to be talking about subnet masks and subnetting, and it's going to continue this whole conversation of playing with these subnet masks. So we still have some time to figure all of this out. So don't panic. I don't expect you to just pick this up instantly. All right? So give it a try, and then, as always, ask questions. Okay? Thank you. Okay, gang. In the last set of problems, we can describe those as network IDs or boundary network IDs. Whenever we looked at the CIDR notation, it always stopped on a boundary, an octet boundary, whether it be 8, 16, 24, okay? This set of problems, however, is for non-boundary network IDs. In other words, the network ID does not stop immediately on a dot. Okay? Let's take our first problem here. And we've got, come on, 10.250.1.1, and we've got a /26. Now, if you recall, the last couple of problems that we were working were a /24, which said that the first 3 octets of the IP address were the network ID. Here we've got a /26, 2 more than the /24, and the /26 literally puts us into the 4th octet. Let's take a look at this. First, we'll write this in a dotted decimal format. A /26 is equivalent to 255.255.255.192. And what I'm going to do is I'm going to write this out in binary so you can see this. So that's dotted decimal. Now let's do this in binary. So that's not what I wanted. Okay, so we'll copy that and we'll paste. So there are 24 ones right there, but we need 26. So this takes us into the 4th octet. And if we convert this, again, 11000000 into decimal, if you remember, that one represents a 128, that one represents a 64. 128 plus 64 is going to give you a 192. Okay? So that's where we're getting the 255.255.255.192. We've got 26 bits turned on in the subnet mask. Okay? Now, the next thing that we need to figure out is something called the block size. And the block size is always going to be the value of the rightmost subnet mask bit. So here we've got all of our bits right here. Okay, the rightmost bit is right there. Okay, so what's the value of that bit? If you look at your powers of 2, that bit is equivalent to a 64. So our block size is 64. Now what this tells you is that we're working with a block of addresses that consist of 64, and specifically if we take the block size, all right, and you subtract 2 out of that, that will give you your number of hosts. So let's do that. So my number of hosts is going to be equal to my block size minus 2, or in the case of this problem, it's going to be equal to 64 minus 2, which is going to give us an answer of 2. So 2 is our number of hosts that we're going to have. Okay? Sweet. Now let's take our find out the different blocks. Okay. The next thing that I want you to do is I now want you to count in multiples of 64, and we're going to always start with 0. So 0, 64, 128, 192, and if we add another 64, that's going to bring us up to 255, but we're not going to use that. Okay, so we have blocks based on this block size, and our first block, if you notice, our blocks are going to run, and I'm just going to write this table out very quickly. So I've got a 10.250.1.1 and so my network ID, I'm always going to be working in the last octet. My first, my last, and my broadcast. So the network ID here is a 0. The first address is going to be a 1. The last address is going to be 62. And the broadcast is going to be 63. Okay? And the way I can show that to you, let's do this. If we look, so the first 26 bits are network ID, right? And then the last 6 bits are host address. And just to okay, so they stand out a little bit. Now our first block is going to, if you look at this, is going to start out with a binary 00. Then our next block (0, 1), and I'm counting in binary 1, 0. This is why it's so important that you understand the conversion between binary, decimal, and hex. 1, 1. Now, what's the value of this 1? If you have 1, 0, 1, followed by, what is that value? Okay, that value is actually a 64 in, okay, this, well, all zeros, so that's pretty easy to figure out. This is going to be 128, 10, and this is going to be 192. Okay. So do you see how these blocks work? Okay, we identified the blocks up above here, 0, 64, 128, 129, simply by doing multiples of 64, starting with 0, okay? And not to exceed 255. So our first block ranges from, starting with 0, okay, ranges up to 63 because we can't go higher than 64. Okay, and let me show this to you. So if we look, let's erase this. And that's our network ID. Then, if our first host address is going to be the zeros with a 1, okay, let's jump to broadcast. So 00, because that's our block, that's the network ID portion here. That is equivalent, if you convert that into decimal, you're going to come out with 63 base 10, and that is our broadcast. Now we're going to go back again, 00, then 111110. One less than the broadcast is going to be our last host. Okay. So this is how I've gotten these answers here. Our network ID was 10.251.0. Our first host address, 10.251.1. Then our last is 10.251.62, and then 10.251.63 for our broadcast. Okay. Again, we had 6 host bits. And if you were to do 6 to the 2 minus 2, that would give you 62 hosts. Okay? 62 hosts. All right. Let's work through the next problem. I'm going to stop the tape and we're going to clean up some of this and we'll work on the next problem. So our next problem, we're looking at the IP address of 148.17.9.1. Now that is a host address, okay? However, the question is, we still need to figure out, okay, this host address, this IP address belongs to a range of IP addresses, and that's what we're trying to figure out. You'll notice that rather than a /24 now, we're doing a /16. And if we look at the subnet mask in a dotted decimal format, let me get down there, that's going to be 255.255.0.0. Okay? And let's line that up above. Also, let's just put this in there. So there are our 16 network bits. And there are the remaining host bits. Okay? Now in terms of the network ID, very quickly, the 148 will come down and the 17 will come down, but this is going to be a 0, our third octet is going to be a 0, and our fourth octet is going to be a 0. So that's your network ID right there. Okay. So next, what we're going to try to figure out is we're going to figure out what are our host addresses. What is the first host address? What is the last host address? What is the broadcast address? One of the things that questions we can answer very quickly is we can say, all right, how many hosts am I going to have? Well, again, if you remember the formula, 2 raised to the number of host bits, and that should be host, not nost, minus 2 gives us the number of host addresses. So looking down below here, you'll notice that I have 16 host bits. So in my formula, if I go 2 raised to the 16 minus 2, that then calculates out to I think 65,536. Just do that real quick in my calculator. Move that over here, and we will go to scientific, and we'll say 2 raised to the 16 gives us, yes, 65,536. Then we say minus 2, and that's going to give us 65,534. That's the number of hosts. And let me minimize that. That's the calculation we got there. Okay. So let's go after our first address and our last and broadcast. So if you will, our first address, you know, I've got again, I'm writing this in decimal rather than writing it in binary. 17. Now this is going to be in binary, and your first host address is going to be all zeros except for the least significant bit here on the right, which is going to be a 1. So our first host address is going to be 148.17.0, because we've got all zeros here, .1. All right, let's do our next one. This is going to be our last, 148.17. Then again, this is going to be our, well, I'll tell you what, we'll do the broadcast address, which says the broadcast address, all the host bits are 1s. So I've got 16 host bits. I'm going to make those all 1s. So our broadcast address, because if you remember, 8 binary 1s is equivalent to a 255. Our broadcast address is 148.17.255.255. That's the broadcast. And I'll put first host. So what is our last host? So we'll put in the 148 and the 17. Now watch this. The broadcast is going to be one less than, or I'm sorry, the last host is going to be one less than the broadcast. So we put in 11111, 8 ones here, and one less than all of these ones is going to be a 0 there. Okay? And the address is going to be 148.17.255.254 for the last host. Okay? I hope that that helps you out. We're going to do another segment on the other problems that we've got, and these are what we refer to as non-boundary network IDs. Okay.